Okay, welcome to viewers. Today we will discuss about graphs of linear equation. Now, what is actually graphs? What is graph? It's a drawing or picture that re- reflects the pattern or change of one variable with respect to another variable. Sometimes it may shows the relationship between two or more variables. Now, you might have observed weather report in your mobile, right? it it might reflect a pattern of change in temperature like this. Means in this direction, if you see the days, in this direction you might observe the temperature in degrees Celsius. It might be falling sometimes, then increasing, then again temperature might be falling sometimes, like this. Similarly, you are more familiar with the game of cricket. You might have observed that the uh, pattern of change in run per over. Say for example, this side reflect uh, overs, and along this side you represent this runs scored by a team. Suppose India is batting, you might have observed this type of curve like adjoint line segment. Maybe run rate is falling, then again increasing, then falling, example, and in between this you will observe fall of wicket like this, right? Similarly, suppose this represents the batting pattern of India, then again you will see another team, say for example in the second innings Australia was batting, then you will observe this type of curve. Maybe at the beginning they were performing better, and suddenly wicket starts falling and they end up in losing against India. Suppose this type of curve you will observe in the game of cricket. Now let us talk about the graphs of linear equation. Now think about a linear equation. Say for example, x minus twice of y equal to 5. Suppose this is a linear equation in two variable. Now let us find some solution. This implies x equal to twice y plus 5, right? So we will try to find a few pairs of solutions for this equation. Now you see, when y equal to 0, when y equal to 0, what would be x? In that case x equal to 5, right? When y equal to minus 1, what would be x? In that case x equal to 3. When y equal to minus 2, then in that case x equal to 1, right? Similarly, when y equal to, say for example, 2, in that case x equal to 9. Like, now let us represent this Cartesian coordinates in xy plane. We will try to find the graphical representation of this linear equation. Suppose you treat this line as a axis of y. You treat this as the axis of y dash. Now you draw horizontal axis here. Let this, you treat this as axis of x dash. So this is the origin, right? So coordinate of origin is 0 0. Now you try to represent the first pair of coordinate, x equal to 5, y equal to 0, abscissa 5. So counting from here 1 2 3 4 5, and y equal to 0 means this point only. So this point reflect 5 0. Second coordinate is 3 1 minus 1. Abscissa is 3. For counting from origin 1 2 3. Ordinate is minus 1, so it is negative coordinate. So you have to go downward. This point reflect 3 minus 1. Second coordinate is 1, minus 2, x equal to 1, y equal to minus 2. 1, 2, minus 2. So this reflects 1, minus 2. Third coordinate is x equal to 9, y equal to 2. So counting from 1, 2, 3, 4, 5, 6, 7, 8, 9. Y equal to this time 2, positive, so it is in the first quadrant. This point reflect 9, 2. Now if you join these points, so see the result. If you join these coordinates, so you got a straight line. Say for example this line is AB. This line is represent, suppose AB. Now you see the graphical representation of a linear equation is a straight line. You will always find a straight line. Linear equation always represent a straight line. Like similarly, let us think about another linear equation. Say for example 2x minus y equal to suppose 1. Suppose this implies y equal to twice of x minus 1. Now let us find a pairs of coordinates which will satisfy this equation. So you try to find a few points. Say when x equal to 0, what would be y then? Minus 1. When x equal to say 1, what would be y then? Y equal to 1. So we only find only two pairs of solutions for this equation. Now let us try to represent in the graph. When x equal to 0, y equal to minus 1. X equal to 0, y equal to minus 1. This point. That means this point reflects 0, minus 1. When x equal to 1, y equal to 1. X equal to 1, y equal to 1. 1, 1. Now you join these 2 points. Now again you got a straight line. Like now this line reflects 2x minus y equal to 1. And this line reflects x equal to 2y plus 5. So we conclude that to draw the graph of a linear equation, you have to know at least 2 pairs of coordinates. Right? But that means to draw a line, you need at least 2 points on the line. Now you remember a linear equation in 2 variables have infinitely many solutions. Why? Now you see, we know that a line has infinitely many points. Now in this straight line, there are infinite numbers of points. Right? So that means every point on this straight line is a solution of this linear equation, x equal to 2y plus 5. Similarly, every point on this straight line is a solution of this equation, 2x minus y equal to 1. So that is why we say a linear equation in 2 variables has infinitely many solutions. Now let us consider a few more equations. Suppose x equal to 2. So x equal to 2. How will you find a graph of this equation? Let us treat this line as an axis of y dash, and treat this line as axis of x dash, x. So this is the origin. Now x equal to 2 means it's a linear equation in 1 variable. So x equal to 2 means irrespective of any values of y, x equal to always 2. For any values of y equal to 0, y equal to 1, y equal to 2, y equal to 4. That means you can consider any values of y. For any values of y, x equal to 2. So let us draw a line for this linear equation. When x equal to 2, y equal to 0. That means this point. When x equal to 2, y equal to 1. This point. When x equal to 2, y equal to 2. This point. When x equal to 2, y may be minus 1 also. When x equal to 2, y equal to minus 1. This point. So let us draw a line for this equation. Now you see this line represent x equal to 2. So x equal to 2 means it's a line parallel to y-axis. X equal to 2 is a line parallel to y-axis, right? Similarly, let us draw the graph of this equation. Suppose y equal to say 5. Now you find a pairs of coordinate for this equation. That means for any values of x, y equal to 5. For any values of x, y equal to 5. Means y will be always 5. Now you see for x equal to 0, y equal to 5. That means x equal to 0, y equal to 5. Count 1, 2, 3, 4, 5. This point. X equal to 2, y equal to 5. X equal to 2, y equal to 5. X equal to 2, y equal to 5. X equal to 0, 0, y equal to 5. This point. This point reflect 0, 5. X equal to 2, y equal to 5. This point. X equal to minus 2. Minus 2 means here y equal to 5. This point. X equal to say minus 5, y equal to 5. X equal to minus 5. 1, 2, 3, 4, 5. Here. Y equal to 5. That means here. This point reflect minus 5, 5. Now you join these points. So you got a straight line. This line reflects y equal to 5. So y equal to 5 is a line parallel to x-axis. Y equal to 5 is a line parallel to x-axis. So we conclude that x equal to any constant, x equal to any constant, 5, 2, 7, minus 1, minus 3, x equal to 2. If you take x equal to any constant, x equal to a is a real number, then you will got a straight line parallel to y-axis. And when y equal to suppose a means any real number, any constant, then you got a straight line parallel to x-axis. Now what is x equal to 0? What would be x equal to 0? Suppose x equal to 0. Now let us find the line for x equal to 0. This is y-axis, y dash, and this is suppose x-axis. Now x equal to 0, let us find the graph of this equation, x, y. Now x equal to 0 means for any real values of y, say 1, 2, 3, minus 3, x equal to 0. Now x equal to 0 means this point, y equal to 1. Say we treat this as 1, 1, 2, 3. This is say minus 1, minus 2. This is say 1, 2, 3, minus 1, minus 2, minus 3. Now x equal to 0, y equal to 1, this point. X equal to 0, y equal to 2, this point. X equal to 0, y equal to 3, this point. X equal to 0, y equal to minus 3, that means minus 3 is this point. So you got this y-axis, x equal to 0 equal to is a graph, that is y-axis. So when you draw the graph of x equal to 0, you will get y-axis. Similarly, y equal to 0, let us draw the graph of this equation, y equal to 0. That means for any values of x, y equal to 0, x equal to, you treat -1, say 1, 5, say x equal to -5, y equal to 0. For any values of x, y equal to 0. Now you see x equal to -1, y 0, x equal to -1, y 0, means this point. X equal to 1, y equal to 0, x equal to 1, y equal to 0, y equal to 0 means this point only. X equal to 5, y equal to 0, x equal to 5, this is 4, 5, y equal to 0. X equal to -5, y equal to 0, this is -5, y equal to 0. Now you see y equal to 0 means you find x-axis. Y equal to 0 is the x-axis. So we conclude that when x equal to a, where a greater than 0, a is a real number, then it will be a line parallel to y-axis. When y equal to a, where a greater than 0, a is a real number, then the graph of this equation will be parallel to x-axis. When x equal to 0, this would be a line represent y-axis. When y equal to 0, this would be a line which is x-axis, right? This is how we can draw the graphs of linear equation. We conclude that the graph of a linear equation is always a straight line, that is a line. That is why we call linear equation. Okay, thank you for watching. We will discuss some more examples in future. Bye bye.